write those little reports, and you have to cite those ladies. And you cite those, make sure you cite every statistic piece of information that you use. Anybody in here have forensics right now? Okay, so when you write a report, I heard you use APA format for when you write. That's probably what you will use in college too, especially if you take anything with statistics in it. Scientific statistics, math uses APA, nursing uses APA. So you'll be used to using those things. You can use MLA, whatever ELA, whatever they use here, you can use that format. Your works cited page does not count as one of your 2 pages though. You have to give me 2 typed pages for your report, and your works cited page is separate. So make sure that that gets done in 2 weeks, October 19th again. All right, so let's take a look. We were doing your stem and leaf graph for your ages. Okay. Oh, well, the sheet was attached to your 2.1 notes. I didn't hand anything out. It was your 2.1. It was attached to 2.1.
Ms. March, you win your appeal?
The ladies here. There was 2.1 notes. Yes, that's 2.1 notes. Luckily, I did.
That's just working hard.
Oh, got it. Okay. All right, so stem and leaf, guys. We're going to give this a title. Okay, now your stem and leaf, this is your stem, this is your leaf. How many positions, how many digits, or how many places is my stem going to have? Not entries. Like, is it going to, how many of these guys? Is it going to be 2 positions, 1 position, like one? One. Because here I'm looking at my leaf. This is different. This is when we followed through and we did all our other graphs. So they kind of follow that one through all the try-its when you do a try-it. And nicely, they put this age in order. Now, yesterday we had a little problem with logistics here. So give yourself a lot of space because one of these, the 50s, has a big leaf. All right, so now you're going to start with your tens position. The first one we have is a 20. Just put a 2. When we make a key, we'll make a key and it'll represent it as a 20. And that leaf only has 1. You're going to get a very long one for 5. Then we have a 3. Then we go all the way to 8. So make sure you do this. Do this first. So that if there are no 40s, you don't miss not putting a 4. If there are no, if one of them is missing, you're not going to miss it. Now this is nice because look at all your leaves are in order. Make sure they line up when you do this. Line them up to the one above it. Then we're going to take the 40s. Now because they're in order, I have 1, 2, 3 of these, Then keep going for your leaves. 4, 5, and 7. Keep them equally spaced apart. I have 1, 2, 8s, 1, 9, and I'm done with my 40s. If you don't keep them evenly spaced apart, you'll think one bar looks bigger than the other, when in fact it won't. Fifties, I have a 0. I have 1, 2, 3, 4 ones. I have 1, 2. I have 1, 2, 3, 4 fours. I have 3 5s. 1 6. 3 7s. 50s was the big one. 1, 2, 3, 4 8s. And 3 9s. Clearly the largest ages came in the 50s. The 60s, I have 2 2s, 1 3, 1 4, 3 5s, 2 6s, 2 7s. The 70s, I only have 170, and I have 180. There's my stem and leaf. Now, if you turn your page sideways, it almost looks like a histogram, where these are the bars. Like, figure this the bars, if you will. Here's my bars. But now, inside those bars, we can see, and they went by 10s. It automatically will have to go by 10s. But how cool is this? We can see what those exact values were. When we do a frequency histogram, all we see is a bar with a midpoint or an endpoint, and we really can't tell what are those entries inside. These, we can see these entries. We wouldn't have known in the 80s, was it a person that was just 80? Was it a person that was close to 90? You know, now we know that this person was 86. If there were no 70s here, then this 2 would be missing, but you still need to keep the 7. It's your, like your space folder. So as soon as you get your first stem, put them all down. Just keep going in order so that you don't, when you're going through your data, you don't miss that one. You would want to show that there would be no 70s here, if there were none. So a stem and leaf has an advantage where you can see each individual part. Do we see it used that much? I don't really see it used that much, but it has its good uses. Questions on this one at all? No? All right. We're just going to spend a little time with these other ones because these will drive you crazy. A dot plot. If you kindly look at, I'm not going to do theirs and then do one of ours because it's kind of redundant, but a dot plot is nice. It also kind of looks like your bar graphs. If you turn to page, let me get to the page, 57. They make a horizontal axis, a number line, and unfortunately this data isn't arranged from highest to lowest either, but you're going to take your lowest number and your highest number. So your lowest number is 70 something, 78, so maybe start at 70, and your highest number is 159, I think it was. No, maybe not. 159 or 160, something like that. So you want to space your number line all the way out so that it goes to 160. And you could do this by 5s, you could do this by 10s, whatever it gets to get you to 160. And then what you do is, now whatever it takes to get there, again, just make sure you have a continuous number line. There's no gaps in this. You're going to plot your points. Again, you have to pay attention to everything getting lined up. So kind of imagine that you have a line above this number line to start with. So my 155 is going to go over here with the dot. My 159 is going to go over here with a dot. This needs to be on the same line. All of those first entries have to be like, so that I could put a ruler and go right across it. Look at the one in the book. See everything how it's lined up on page 57? You see those points all lined up? Yeah? They're all lined up. So at any time you could put a ruler and you could measure across that line. If you did this, then put the other one down here, and then, God bless you, and the first one up here, and then did this, and spaced these out, and then did these, you would never be able to tell by looking at this who has the most. So if everything is lined up, everything falls on the same line, then the next one falls on the same line, then the next one falls on the same line, you'll be able to tell those dots who has the most. It kind of looks like a bar graph for each individual entry almost. But now you could say, oh, if you look at theirs, which is the highest one? Which is the highest one on page 57? The highest vertical set of dots. 120 what? Look at the number line. 126. So 126 had the most entries. If we looked at your stem and leaf, we had to kind of go into that leaf, look for those stems, and then see which one had the most in there. But this one, it kind of pops right out of us, doesn't it? This is more of an individual entry. So we're going to make one for your ages of your 50 most powerful women. We're going to do this one. We do a dot plot. We try one of each. So let's make a number line. What does my number line have to go from? Oops, we might as well make it a little bit lower because we have a very large 5. What does this have to go from? 20 to 90. Now if you go like put too many tick marks in there, it's real confusing too. If you put too few tick marks in there, you're not going to tell the difference between a 27 or a 28. So if you can, first go by 10. Space them good enough apart, go by 10. And then in between, make your 5 ticks. I would go as far as the 5 ticks. I wouldn't waste my time doing all the ticks. If you're going to do this professionally, then you are going to build yourself a number line. You're going to do it on a computer. Now, for each one, you're going to put a dot. Bear with me because my board is always off. At 26, I'm going to start my dot line right here. There's my 25, there's my 26. At 31, there's my 31. This should line up right here. This should line up. At 35, put a dot. Same space apart. You guys should be doing this in your notebooks. At 37, put a dot. At 43, first put one dot at 43. Now, I got 3 43s. So come up a little space. Come up a little space. That is where my next lines are going to go. My horizontal lines. They have to line up with those dots. So 44 has one right next to it. 45, I'm at the 45. 47. 48 has 2 of them. Make sure the next dot comes up to where the other dot was. 49 has one, and 50 has one. I'm a little bit off on my dots. And 51, because my board's a little off. Then 51 is going to have 3 dots. Make sure they're lined up. 4 dots. So do you see how your dot plot goes? Alright, so finish your dot plot line. Make sure they're lined up. This one's annoying. I'm not a fan of the dot plot. But if you want to know individually your data, it's a good way to see it individually. You can use it for that. You can put it in your notebook anywhere. It is annoying. And again, we're going to give it the title. That's why we don't do theirs and then do ours, because it would be double annoying. That one. Good. Get the hang of it. Yeah. That means you should probably try to space your line out a little bit more.
The
Yeah.
floor is just like,
Yeah, you can't get fine in there. Like, I can't do that with this either, because first of all, it's always off. I put a dot and it comes in a different position. So, after your dot plot is done, did you see which exact age occurs the most? According to your line of dots, which age occurs the most? 58. So your 58 should be the highest one, right? And you can kind of see the flow of once you do this, you can kind of see where they are. A lot of your dots will come right in between here somewhere. They're all going to come right in here because that's where my major ages are, between my 50 and my 60. So these should be a little bit higher. And then I got kind of a straggler or two to the side, right? And a 72, and then all of a sudden I have an 86. I have an 86 out there. All right. Are we good with this one? We're still working on it? Okay. Go ahead, finish it up. You can kind of get to see them. The one thing about a pie chart is getting the percentage out there. You can also do it with an angle, and you probably did a pie chart with an angle, maybe in geometry. I don't know. But I'll do the angle, but we very rarely see the angle used because most people that you're presenting this to will say, why do I care that that's 35 degrees? Why do I care that it's 35 degrees? I want to know what percentage this is for me. So we'll do an angle as well as relative frequency. Now remember with the pie chart, you're going to get a circle graph, and this is going to represent 100% of your data. So since it's based on 100%, you're going to add up all your frequencies. This is your frequency. You're going to sum these up, and you're going to give me a relative frequency, a part over whole, all the way down. So this is the one in the book. They sum this up. You don't have to do with this one. Just follow along in the book. It's on page 58. I just want to show you how they get the individual parts. So now, your relative frequency is part over whole. You can give this as a decimal, but since we're going to use a percentage, multiply it by 100 and give me a percent. So the reason we use 3 decimal places is this. if I took 2 decimal places and then I multiplied by 100, it looks like I have a perfect percent. If I rounded this to 27 and I moved it, I get 27%. It really wasn't exactly 27. So you like to show them a little bit of a decimal so that they know it wasn't exactly 27. So go 3 decimals, multiply by 100, and give a percentage. You're going to do the same thing here. We're going to do one together, but I just want to explain where these come from. So they get 0.483. We're going to multiply it by 100, or move the decimal 2 places to the right. And this is where their numbers come from. So this one was 20.6%. It's in there. It's in the book, and then we'll do one ourselves. This one is 4.6%. These should approximately add up to 100%. Sometimes they're like 99.9 or they're 101 point something, just because of the way we round it. When you have an even amount, generally 2 round down, 2 round up. If you have an odd amount, then sometimes 3 round one way, 2 round the other way, and your number might be off. To find an angle, how many degrees are in a circle? 360. So we're going to take this number and multiply it by 360. So this would be 95 degrees. Take this number and multiply it. Do it before you convert it into a percent, because otherwise you got to convert the percent back again. Multiply it by 360. This becomes 174 degrees. Multiply 0.206 times 360, 74 degrees. 17 degrees. These should approximately be 360. Now, when you make your circle graph, this is based on 100%. This is what I do. This is my way to do it. And everybody has a different way to do it. I have to put these percents in my circle. So I kind of separate my circle into fourths, because each quarter is worth 25%. So it gives me a better feel for where I'm supposed to be. Now go for the ones that are close to the 50s, the 75, the 25s. So I notice I have this big one right here. Isn't that pretty close to 50? But would it be before 50 or after 50? Before. So I'm going to use that. I'm going to come down here, and it's going to be just a little bit before. So this whole section, I put the title, is people with your bachelor's degree. And I put the percentage here. Now, if I added these two up, and just like roughly rounded it, 27 and 48 give me what? 75. So, isn't that 26 almost like right up to here? Yeah, this is my associates. And I have 2 left. Which one's bigger? 20 or the 4? 20. I better have one that uses a lot for 20. 20.06%. This is the master's. And then this is my 4.6%. If you can't fit it in, do this. Just put a little arrow and put it outside of your circle. Again, this needs a title. These are my degrees in 2011. Does yours have to look exactly like mine? No. But what I will check is perspective. Is this the biggest chunk? Did you make it more than 50%? Did you kind of go over the 50%? Or did you stay a little under the 50%? And it doesn't matter if it took this 50%. It just still has to stay a little bit below that line. And if 26%, a little bit past the 25. I don't care where it goes, as long as you can show me that you used it all and they're in relation to each other. I don't want this 26 being half of my graph and then 4% being the other part, because 26 is a lot larger, right? So just kind of get a perspective on it. So let's try one together. All right, so they gave us another one to do. So what's the first thing we have to do?
Emma?
Add them up. Anybody have a handy dandy calculator?
Nope.
All right, so we add them up. 1940. Then what? Good. Part over whole. All your parts over the whole. This way, if you do this, you're guaranteed to get 100%. By the way, this is one of the graphs that people are very misleading with. If they give you a circle graph, the first thing you should always do is make sure your percents add up to 100. Because people can be very misleading when they show their data. And they could show their data using a whole circle, but the pieces don't add up to 100. Or they're over 100. So be careful about that. We're going to take it and then we're going to multiply it by 100. Well, actually, let's not multiply it yet. So this will be 0.235, then multiply it, just move the decimal. And make sure that this is approximately 100%. If you want your angle again, take your decimal and multiply it by 360. Some people use angles to make their graphs. In the business world, you probably won't. Because this is what they're looking for, percents. Now, to make your circle graph, again, this we're going to give it a degrees in 1990. We're going to give it a title. And we're kind of going to separate this into quarters. So which one stands out? Which one should we put out there first? 54. So is 54 more than 50, less than 50? More. So it means when I come down here, I got to go a little bit more. So all this in here is 54.2%. This is my bachelor's group. If this is 50 and I used 4, I have about 21% remaining over there. Do I have a category that's close to 21? Yeah, Sarah says, yeah, use my 23. So if I only went to here, that used 21, right? So I'm going to go a little bit more, and there's my 23.5%. That's my associate. And between a 17 and a 5.4, make sure your 17 looks bigger. 17 point, just, 17%. That's your master's. And 5.4 is your doctorate. Doctorate. So I need this to be in a good perspective. Do I have to measure exactly? No. If you looked at your angles, 180 is half your circle. Isn't 195 a little bit more than half? Right, if you use angles? If you use angles, 61% is a little bit more than where is it 50%? Like each quadrant would be 90. So it's a little harder, like 84, a little less than one quadrant. That's my less than 25%. I like the percent, but if you like to do the angles, that's fine too. The angles are a little harder to get because you're dealing with 360 as a base, not as 100 as a base. But we can say from our circle graph, which percentage is better. Like we had more bachelor's degrees than we did very few doctoral degrees. We had a good amount of associates. This is the highest degree that was earned. And master's. So a circle gives you a nice picture of your data. Good? Questions so far? No? All right. We're running a little short on time, as usual. tomorrow we'll start with your, I don't want to rush through Pareto because Pareto, I'm sure you haven't seen before. So tomorrow we'll start with the